Recordings in progress. Good evening, y'all. It is June 6th of 2023. This is Echo Platoon Evenings and Weekends. I'm your host, Jordan West. Today, we'll be talking about higher order functions in JavaScript, the for each, map, filter, and reduce methods. We'll be pretty much working off this README. This README covers the majority of what we kind of want to do, but we might go a little off script when we're talking Python, maybe. I didn't prepare Python side of this because you kind of can figure it out, but we'll talk about it. Cool. So a higher order function is a function that either or both accepts a function as input and or returns a function. Seems like some nuance and a nonsense thing to name, but we're in JavaScript. Why would you ever want to do such a strange thing? It turns out that it gives the ability to write more general and reasonable code. Yes, dry. JavaScript coders think that lines cost 50 cents each. So they will do anything and everything they possibly can to get it on one line. And that is a lot of what this is for. This means you want to avoid repeating yourself. Yep, don't repeat yourself ever, no matter what, God forbid, in JavaScript. Even if it's easy to read, don't repeat yourself. And avoid making silly errors. Okay, I agree with that. Let's look at an example of a familiar pattern you've seen over and over again. So this is a loop in JavaScript. It ain't pretty, but it gets it done. If you're not using for of and for in loops in JavaScript, we need to talk. And if you don't know what that is, I can cover it right now. Does anyone know what I mean by that? For of, for in?
We talked about it yesterday.
Excellent. Use those instead. Unless you actually need to iterate and keep track of the iterator itself, this is not great. And it's prone to making mistakes. So we've got an array. We want to print or do something with each of the array. So 1, 2, 3, 4. We're going to iterate I starting at 0 as long as it's less than the length. Iterate plus, and we're going to write out console.log, doing something with it. Let's see if this is true and honest. Cool. Yep, looks like it's working. What's the problem? There are any number of variations of this pattern. Let's say you want to create a new array that contains all the values in the original array, except they're doubled. So mixing it up just a bit, instead of simply console.logging, we're going to be pushing it into this new array, which means we have to define this new array. So new array.push, you're going to be taking the original array, the indexer, which will be 0, 1, 2, 3, multiplying it by 2. Oh, sorry, I is going to be 0, 1, 2, 3. Index of the array is going to be 1, 2, 3, 4. Multiply by 2, you should get a new array. Rather, new array is going to get 2, 4, 6, 8. Does that make sense to everybody? Do we need to break that down further? Because we certainly can. See if it's full of lies. Nope, does pretty much what we expected it to do. Cool. This works, but there are a couple of minor issues. The first is that you really have to micromanage every little thing. It's a lot of work for a lazy programmer. Plus all those little steps open you up to making silly errors. That is true. Again, why I super don't like these kind of loops. You can write them 100 times and still make mistakes. Fortunately, we can move up a level of abstraction and offload all that manual labor onto something else. We can think of this pattern as basically, I want to start with a list and then do something for each element of the list that can be translated into this function signature. So, easy question, also a hard question. What is a function? I'm going to pick somebody if no one speaks up. In fact, I'm
something. Okay.
Who's talking?
I was going to say it's something that
takes an input and delivers an output.
Yeah.
That's right, Chris. Who else is speaking?
It was Phil. We were pretty much saying the same thing. I was going to say it's something that takes an argument and it, uses it for input and puts out an output.
Oh, so wrong. Does a function have to have an argument?
It doesn't. But
ooh, so you want to change those?
Or you could say that the argument is empty, or
Oops. Oopsies. So I mean, this isn't, I don't have to do this, but I'm just gonna do it to kind of prove the point. So I could be able to just, I should be able to just run this, right? No argument needed. It's just a empty function, no need, it runs. Does someone else or you two want to adjust that explanation a little bit? Maybe that definition of a function. What's another way to describe what a function is? I'm looking for a specific set of words.
Can
and I
you
don't know if
say
y'all
it's
got
like a
them.
block of code that can repeat like the same capability over and over again?
Yeah, you could have stopped at pretty much that first sentence. It's a block of code. Function is a block of code. It's named. It's named so you can run it again. It doesn't have to be named. We have code blocks that can be reusable and not named, but we don't want to get into that. Yes, that is all packaged here. I took 3 lines and made it 1 line. Actually, I took 1 line, added 2 lines to it, and made it 3. But you know, I could get away with this if I was a weird JavaScript coder. That should still work. Yeah, a function is a block of code. And the reason you'd want a block of code is so you can rerun it. I'm gonna put y'all over here so I can keep an eye on you, I think. So I lost my train of thought, but that's okay. So we are going to offload some of that work into a separate function rather than just having one big fat looping function that does everything all at once. We're going to make it dry. The difference between a brand new coder and a little bit higher level coder, kind of where I'd like to see y'all by assessment 1 or 2, is making your code dry with functions. A lot of reasons to make things dry. Less errors, realistically. It makes errors easier to track down. And in a coding language such as JavaScript, that is really, really not helpful. It pays to break your functions or break your work up. I don't want to see a function that takes an array, flips it around, turns it upside down, goes and looks up a bunch of things, pulls them in, changes the names, spits out these objects, and those objects have built-in functions. I want to see one function do each thing. And generally, this is not the quote me on this end all be all, but if you can't describe what it is that function's doing in a very concise name for the function, it probably should not be one big function. I want to see your function named exactly what you expect it to do. And if we're getting to like 15 words, we're definitely too big. Generally break it down to one thing. If it makes sense for more than one action to go into there, use your best judgment. But generally speaking, a function should only be doing one kind of thing, and as dry as you can possibly make it. Because when you have an error, you don't want to say, shoot, I found the error. It's within these 300 lines. You want to break it down to what exactly broke. And when we get into testing, which we'll be doing test-driven development, it's a lot easier to test your code. If you've got do-it-all function, it's real hard to write tests for do-it-all function. It's really easy to write tests for flip the name around function, turn it upside down function, make a call function. As you're writing your tests out, it's a lot easier to see what each one of them is doing, and it's a lot easier to write those tests. Capiche? Keep going. All right, so as we talked about, we want to use higher order functions. So a function that calls a function and takes in an argument and then performs some action with it, spitting out the results of those actions, or a function, or both. It's obvious what some array is, but what about action? It's a function, of course. In the first example, we just pull out whatever the body of the loop and put it in a function. So this action here, we're actually going to be creating a function, and that's what we'll be plugging into the action. Oh my goodness. You see me doing something in VS Code and you say, wow, that's fast. How did you do that? Please speak up. I'm not real fast in VS Code, but I do know some shortcuts. Cool. So as we said, we're gonna have a function. It's going to be called this. It's going to take an array. It's going to call an action. This is the action. It's going to be print message. I'm doing something. So similar to kind of what we had up here, we're now going to be breaking this up into two functions. Then we can just plug it into iterate and do, as I kind of mentioned. This is very pseudocode. We're abstracting it out a little bit. Give me a second. I think my machine's slowing down. Like last class. All right, are we back? I think we're back. Can y'all hear me?
I can hear you, but I can't see anything from what you're sharing.
Yeah, same.
There.
Oh, there it is.
There it is now.
Excellent. I need to start leaving a note for myself to do that ahead of time. It's like my laptop stopped garbage collecting when it's shut. Cool. All right. We're moving fast now. So again, this is just pseudocode. This is kind of what we're going to be doing, but now we're actually going to get into it. Again, I forgot to pause when I threw you all through that loop. Okay, so for each. For each is a common method for brand new JavaScript coders. Most commonly, you can use it to get both a iterator and the value of array if you want to do it that way. But we're going to show you some other things it can do. So the first version we're talking about, that is what for each kind of does. You would take my array for each, and then you would plug in that function, and that should do roughly what we kind of want it to do, which is run through for each of those and do nothing else. You'll notice that our made up iterate and do is slightly different because it's a method available on arrays, so you don't need to pass in the array as a parameter. The same idea. For each manages all the nitty-gritty details of looping for us. All we have to do is give it a function that takes a parameter. In fact, we can make this more explicit by writing it a slightly different way. Okay. So we're going to leave that there and use, oh, I got to keep my array up here. There we go. So running that, using myArray.forEach, which is a dot method, it works. For each is going to accept a argument. And the argument is the function. This one we wrote up here. Oh, sorry, it doesn't even need that. My bad, y'all. It's going to take in an array, and then with that array, we're going to run this function for each of them. So my array for each element, I'm going to plug in element as the argument for print message. Print message takes one thing and spits out one thing. It doesn't know what to do with arrays. It only knows what to do with one single argument. So for each knows to look at this array, identify for each, whatever they are. It could be an array of horseshoes or dogs. It doesn't matter. Each one of them is element, and then we're going to pass to print message as element. This is like defining it. So in a normal function where you define it here and then use it for a for each method, and for all these higher order functions, we're going to plug it in here, which names it, identifies it, instantiates it, and then plug it in. So that just works. This is running this dot for each method. That is almost the same as calling it. In fact, it does call it. This is a call. This is being invoked. I don't have to call my array dot for each somewhere else. When I do the dot for each method, that is calling it. That is going to run it at the time that it is read from the script. with that said, what do we get when we let's see. Read all that. Oh, spoiler alert. If you were to try and plug this into a variable and call that variable, you get nothing back because this function here isn't returning anything. It's doing work, and we can see that. We saw that here, but it's not returning anything. It's running, doing some work, spitting some stuff out somewhere else, and it goes away. It doesn't return anything. And we're going to see this in JavaScript a lot, actually. You're going to see this when we get into React. Think back on this day. You guys are going to try and call, or you're going to try and return the output of an asynchronous function. Asynchronous function doesn't return anything. It does work, and then it dies. It doesn't give you anything back. That's what's going on here. And when I said we need to establish this here, that is not actually necessary. There's no need for that. That was just showing you kind of what was going on. Oops. It's extra. So just to prove it, if we run that, it's going to do what we kind of expect it to do. Actually, here's an even better way to look at that. That's what I meant to do. If we run this line, like I said, instantiating it here is going to run it, because I said it's already been, it is being ran, it's being called, and you can see it working here. But then when you go to console.log, the output of that function that just ran is nothing, because it says I don't actually return anything, I just do work. Did I lose anybody with that? I understand I'm kind of talking about some ephemeral stuff here.
So
The only thing I'm mixed up on is, does that have to do with the fact that the print message function doesn't return anything either? Like we're returning a side effect there instead of a return? Or like, I'm guessing it would probably still do the same thing, but I guess that's what was unclear to me.
That's a good question. No,
Yeah,
it's not
looks like it
calling
still
this.
does.
Yeah, it's not calling. We're not calling this function here. When this is ran, it runs that function and it returns something, but we're never really doing anything with whatever that function's calling. We're just using it. For a for each, we look at some other higher order functions. I believe we're going to be actually capturing this return. Moving forward. What about our second example from earlier where we wanted to get a new array? So this is just saying, hey, remember up here when we wanted a new array with the double values? That's the same block of code. So we're not working with this. We're just saying, hey, remember that. Remember earlier we were looping through, we were doubling the value, sticking it in a new array, and then we were checking the new array. We can do this with mapping. Mapping is another higher order function. Mapping, sorry, I'm going to say mapping as a verb. When you map, map is going to output a new array as such. So let's write a new function. I'm going to get rid of this because it didn't tell me to do that. We have a new function. It's called double. It takes an element. It then returns element times 2. So we are going to be actually doing something with this array. But again, the map doesn't just call something and do something random and arbitrary. It actually takes an array and returns an array. It has to be given an array because it's going to return an array. Doesn't produce any side effects, though. It just creates a new array. So generally what you're going to be doing is setting a new value, taking an old array, run a .map on it. Whatever it is you're going to be doing with that map, And whatever the product of running this function is going to be your new array here. So we'll prove that. We're setting a new value called the return value. I like that name. I think that's a good name. I like the word return in my returns. We're going to set it equal to my array, but we're going to map it. And we're going to be using this double function here. So it's going to look at this array, say, all right, I'm going to map it. Let me look at each value in this array and spit out a new array, which is going to be called this. Once for each of these elements, I do this thing. So it's going to step through, read this one, double it, put it in a new array, read it, double it, put it in a new array, etc., etc. Output that array as return value. Look at that. It did exactly what we wanted to. Do you all follow me?
I guess my question is, are you trying to make us realize why is it better to use map than for each? Or is there a clear situation when one is better than the other? Because they seem very similar to me.
They are very similar. The difference is for each doesn't return anything. Map does return something. You could use a for each to establish a variable and pump those into that variable that is global and then be used somewhere else. But we don't like global variables generally. I would rather say, hey, that's a known array. I'm going to create a new array right now, and it's going to be based off of that old array. And I'm not going to touch the old array. I'm not going to have a blank established array laying around for later use, because that's something you'll see a lot now, and you won't see a lot later, is just empty variables called new array equal to empty array and then used somewhere else. We don't like that. Remember, each one of these lines costs 50 cents when you're in JavaScript. So this is not ideal. There's no need for that. We can just later say, hey, this new array is actually this. We don't waste any time setting up some array earlier on. Oh, sorry. So they do similar things, and you can utilize them to do the same things, but one returns output, one does not.
So would this make the high order functions better in terms of like time and space complexity compared to just doing a regular for loop and then adding an empty array and all that and
Nope.
pushing it up? Okay.
Nope, not more efficient. Not more efficient at all. Your lookup times are going to be the same because they're doing the same thing under the hood, right? In fact, it might even be slower. But we're not too worried about that right now.
It is slower, by the way.
Yeah, I'm pretty sure it. Yeah, I believe it is also. We could prove that if we wanted to. We won't though. All right. Like I said, map doesn't do anything else. Nothing outside of itself has changed. It doesn't need to change the original array in any way. Map will always return a new array that is the same size as the original. But what if you wanted just a subset of those? Filter. Filter's nice. I like filter. Filter is not going to necessarily make changes to that array and then, well, it's not going to make a new array with some changes. It's going to keep the array and remove stuff. So we're going to make that array smaller. Filter does kind of what you expect it to do. That's a good name. Filter handles the case where you want to iterate over an array and return a new array containing only elements that pass some kind of test. Technical name for this is a predicate. I like the word filter instead, though, because I was a mechanic. Because the function you pass it need to return a Boolean. Needs. Let's say you want to create a new array with only even numbers. First, you'll need to create a predicate function that takes an element, performs some test, and returns either true or false. All right, let's get rid of all that. Here's our new predicate function. Is even. Does everyone understand why this returns true or false? I don't need to check it and then return true or false. if the element modulo 2,
Truthy, falsy.
yes, that's what we're talking about, is truthy or falsy. If it's a 1, or rather, if it's not equal to this, it's going to return false, because that would be a false statement, and then true, vice versa. Easy peasy. I like that. Then, just like others, we plug everything in. So, nothing too crazy here. Const return value. We're going to my array. We're going to use filter. Filter needs a function that performs some filter action. It again needs to return true or false values. And if it gets a true value, it's going to plug it into this new array. If it gets a false value, it's not going to plug it into the new array. It's like a bouncer. So 2 and 4 were good enough to get in. Does that make sense to everyone?
Yes. Can you store those as well? Like if you're like, I guess if you had to filter like more than one thing from an array, so you could like maybe store one result in one variable and another in another. I don't know if that's a weird question.
What do you mean? Are you talking about building 2 arrays?
No, just like when that returns, can that return be stored in a variable? Because when we were talking about for each, you were saying that it couldn't. So I was wondering if it falls under those guidelines or not. Like if you were to filter even numbers and store them in one variable, and then filter odd numbers and store them in one variable, like would you actually be able to console log those, or would they not return?
I feel like your explanation is simple, but I'm still not grasping what it is you want to do. Can you give me a real world example?
I'm basically, well, even with just like that result, like we could just check by seeing if like if you put that result into, well, actually you're doing it right there with return value. So that answers my own question. So
Okay.
sorry about that.
Yeah, no worries. Filter is going to return an array just like map does. The difference between map and filter is filter is going to make it smaller. Map is going to return an array of exactly the same length. Unless you do some weird stuff. I think it actually has to, so never mind. Reduce. Reduce is the last standard higher order function. It's different from the others because it only returns a single value. The function you pass to it has 2 or 3 parameters. So you want to get the sum of every element in an array using a for loop. You might do this. So there's our array. Sum 0. Iterate. Sum plus equals each one of those. You should get 10 because 1 plus 2 is 3 plus 3 is 6 plus 4 is 10. Not too bad. That's not too ugly. Why do it in 5 lines when we could do it in 4 lines? So reduce is going to, as they said, it's going to have, what is it? Lost my spot. 2 or 3 parameters. All right, so that's what it wants us to build. Function sum accumulated current element, return accumulated plus the current element. Accumulated is what is going to be the running number on this, or the running value on this. We're turning one value when we're done. Accumulated is going to be that running value. So return value is equal to my array dot reduce. Run it through sum. Accumulated is going to be 0. Current element is going to be everything in the array. Should return 10. Looks like it returned 10. Reduce is going to need the running value as well as an argument to iterate through that. When you call it, That's all you do.
How,
This is
how do
also,
you establish
what's that?
the starting value when you use that?
Say
Every
that
time
again.
I use reduce, I've had to establish a starting value.
I believe it's going to assume 0.
So if you're multiplying things, then 0 would not work properly, correct?
Yeah, let's find out.
Hmm.
Maybe
Yeah, I
it
think the
assumes-
difference is that you're passing in the sum function. If we were to like create the function and the reduce, I think you would have to establish that starting.
So is it more common to create a function to pass into one of these methods, or do most people write what do they call them, fat arrow functions?
I would say most people do fat arrow functions, in fact. And that is generally what I've seen, where you would open this up into that guy and then do all of your work within this, which I think is just the ugliest thing in the world, but that's what people like to do. You would kind of pack all your code from here within here, and that is the JavaScript-y way to do that. I think we're not showing that right now as to not pile on too much, but that is conventionally how you would do that. I wish I had ran through this on my own real fast. Let's see. I think you would need to establish it as in, that.
I
Oh,
think you
my-
do it at the end with a comma after the last bracket or squiggly bracket, kind of in between
I-
that and parentheses maybe. It's like
I
comma starting value.
I think you're right, and we'll walk into that when we get there. I don't want to riff with JavaScript when I'm already not the strongest JavaScript coder, but we can cover how we do that right after this when I'm not recording. But yeah. No, but to answer your question, yeah, generally, if you're using these higher order functions, I don't generally see them plugged in like this. This is more kind of teaching how they work. Generally, yeah, you'd fat arrow them in. So all
Not
together.
that, sorry,
What's
I was
that?
gonna say, not that it matters, but if you wanted to use the fat arrow key, all you need to do is define the variables within your parentheses and then use a fat arrow. So like if you wanted to multiply, you could just say A comma B and then A times B or A plus B.
Gotcha. Okay. Yeah, we need to. I mean, I can look up the convention for that really fast. Learn it all together super fast. Oh, hey, look at that. You do it like that. So it infers that accumulator is the running value because of the first one passed into the reduce function. Where is reduce? So reduce, its positional arguments are a callback function and an initial value. Oh, is it taking it backwards? Ooh, I think it'd be backwards from what you expect it to be, though, does it? Yeah, I think we're actually doing it reverse from the way function, or sorry, from the way that reduce expects it. So reduce, looking at docs, these are good enough. The first argument is the callback function, and the initial value is the second. If not defined, I guess it's going to assume some things. Let's see. If initial value is not specified, accumulator is initialized to the first value in the array. So if you don't give it one, it's going to assume that the first argument is going to be the starting point. So it would assume that 1 is the starting point. Interesting. Cool. It's actually backwards, so you wouldn't pass it in. How ours is doing this? Oh, no, I guess that does work. No, it does work the same. Okay, gotcha. Getting down that rabbit hole. This is reduce. You can look up how reduce works if you want to use reduce. Generally, yeah, you would kind of run it like this. They're not really fat arrowing it here, though, are they? Jordan's going to look that up to make sure it's nice and clean. And yeah, also my JavaScript skills are not strong enough to just riff that. Let's say you wanted to take a list of integers, filter out all the odd, double those left, and sum the double integers. This is just JavaScript showing off. Well, my language can do a bunch of dot methods in a row and get something that outputs kind of what you wanted. Very cool. Who cares? Doesn't matter. Everyone can do it. That's not clean. Dot filter, dot map, dot reduce. Maybe it makes sense if you wrote it. If you turn that in, I'd be like, I don't know what you're doing. I don't want it to look at this, look up here, look up this, look up there. But yeah, JavaScript is flexing, saying I can do dot higher order functions really, really easily. Why is mine 32? What did I mess up here? Did I mess up? It's supposed to be 12. Why is mine jacked up? That's not right at all.
Didn't we change our reduce to multiplying? So I think reduce is supposed to be plus. We were messing around with it.
Yeah, we did. There we go. Yep, that's right. Cool. So that all works. I don't personally love these. They can be really handy. The more JavaScript you write, the more you'll use these kind of things. If you don't like them, you don't really have to use them. Like in Python, you would do this by hand. If I wanted a function that returns an element, or sorry, not return, returns an array, I would just do that. These are built in to save you some time in JavaScript, and are commonly used, but they're not some secret special thing that you need to super utilize all the time. We will be using them in assignments today, and these are good assignments for these higher order functions. But when you get to Python, you're going to have to look up how to do that. That's part of the challenge today is, you know how to do it in JavaScript, Google how to do it in Python, or figure out how to do it in Python, replicate it yourself. Today we're doing sum pairs and Armstrong numbers. Armstrong numbers, real quick, an Armstrong number is an n-digit number that is equal to the sum of the nth powers of its digits. So 5, for example, 5 is a single digit, and 5 to the first is equal to 5. But it gets more complicated when you get to the larger numbers, but not that complicated. So 371 is another Armstrong number because it is 3 digits. So it is each of these to the third added together should equal itself. I don't know what you'd want an Armstrong number for, but they exist, and you're going to try and track them down. So to check the logic or just verify this, if you wanted to verify 371 was an Armstrong number, you would need to iterate through each of the numbers. You would need to raise them to the length of the integer's power, save that, and then add it to the running value. Looks like a good option for reduce. In fact, that's kind of what we did. on the page before. We took an array, did a bunch of stuff to it, and returned a single value. I'm not going to go much more than that. In fact, I've given away too much. You have to figure out how to do it yourself. The next one, sum pairs. Return an array of arrays. Within those arrays, you're going to have the pairs. So sum pairs is going to take an array of numbers and a value, an integer. All of these that add up to equal that integer are going to be the correct answer. You're going to put them within an array, Why would you want to do that? Well, sometimes there might be more than one correct answer. So I want an array, or kind of a tuple, of each of the pairs. Stick those within an array. So if 7 is the desired number, 2 and 5 are an option, and then 3 and 4 are an option, because 2 and 5 and 3 and 4 both add up to equal 7. This can get tricky if you're just iterating it by brute force, because you're going to get something back like possibly, if you're double looping, 2 and 5, and also 5 and 2. We don't want that. There's not 2 instances of 2 or 5. Does that make sense? Do these challenges make sense? You will do both of these in JavaScript and in Python. That is the lecture. I'm going to stop recording.